Most discussions about the AI boom center on three names: Nvidia for design, ASML for lithography, and TSMC for the physical fabrication of the silicon. But as chip architectures shrink toward 2 nanometers, the industry is running into a wall of microscopic friction. At this scale, manufacturing isn't just about precision, it's a battle against the physics of atoms. At the atomic scale inside a 3D chip stack, even a minor layer deviation causes the entire unit to fail. For a foundry producing $10 billion annually, a 1% yield drop loses $100 million. A microscopic defect threatens the bottom line. The entire AI hardware revolution relies on finding a way to manage this fragility. It has created a massive, highly profitable opening for any company capable of spotting these defects before they ruin a production run. That is the role KLA plays. They operate as the diagnostic layer, using high-precision optical tools to scan wafers for defects measured in atoms. KLA occupies a different space than the chip builders. Their sole focus is process control. They don't build the logic, they provide the equipment that confirms the logic is physically functional. In an industry where complexity is the greatest enemy of profit, KLA has found a way to monetize the difficulty of manufacturing itself. They are selling manufacturing confidence to the world's largest foundries. This reliance on KLA is deepening as the industry moves toward advanced packaging, which is becoming the primary growth engine for AI hardware. Advanced packaging involves taking various specialized components, like HBM memory and logic processors, and stacking them into dense, three-dimensional structures. This vertical integration drastically increases the number of potential failure points in every single unit. KLA's performance in this sector is reflected in the data. Their advanced packaging revenue reached $635 million in 2025, a 70% year-over-year increase that is nearly double the growth rate of the broader packaging market. This growth is a direct result of physical necessity. As chips become three-dimensional, the probability of defects multiplies, making high-volume production impossible without constant diagnostic oversight. The harder these chips are to build, the more central KLA becomes to the manufacturing process, structurally expanding their reach into the next generation of AI hardware. This physical indispensability translates into a specific operational advantage. Because these inspection tools are critical to a factory's yield, they can never be allowed to stop running. KLA moved to a predictive maintenance model. Their tools stream performance data to the cloud, spotting mechanical drift before a tool goes offline. This creates a $2.5 billion subscription-like service business, growing for 53 consecutive quarters with a 95% renewal rate. The sheer difficulty of AI manufacturing creates a durable, recurring revenue stream that stays active even when the broader equipment sales cycle slows down. KLA's technological moat is best demonstrated by how they have handled intense geopolitical friction and trade restrictions in the Chinese market. While several major American peers have seen their market share in China erode as domestic competitors gain ground, KLA's position has remained largely unchanged. This chart shows the competitive landscape in China. Despite local pressure, KLA's largest domestic competitor holds less than 1% of the process control market. Because KLA's tools are so deeply integrated into the specific physics of a fab's production line, the cost of switching to an unproven domestic alternative is economically irrational. These combined structural advantages have shifted KLA's identity on the public markets. They have largely moved past the traditional boom and bust cycle of the semiconductor industry. Today, their visibility extends into 2027, with foundries currently under construction already locking in their delivery slots. The result is a profile of extreme financial efficiency. KLA maintains gross margins above 60%, a return on invested capital of over 30%, and converts 95% of its earnings into free cash flow. These figures suggest that KLA has graduated from being a cyclical hardware vendor into a highly predictable structural compounder. The broader market continues to focus on consumer hype and AI software, often overlooking the physical reality of how these chips are actually made. While companies like Nvidia represent the potential of AI, KLA is the one monetizing the complexity required to bring that potential into the physical world. KLA now sits alongside ASML and TSMC as a critical bottleneck in the AI supply chain. They have made themselves an essential partner to the industry by ensuring that the most complex processors ever designed can actually be manufactured at scale.